Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Planetary Nebula and Death of a Star. Now, according to the accepted astrophysical theory, a star forms a planetary nebula when it dies. The planetary nebula is of ionized gas around a star. There are many examples of these planetary nebula which can be observed from Earth, resulting in many amazing photographs existing of these objects in space. And we can see some of these images. Now, there's always a star at the center of the planetary nebula or cloud, which often exhibits a ring or toroidal shape, as we can see here, this ring structure. Or we could say it's toroidal in shape. And this one here is called the Ring Nebula, or it's also referred to as M57. And this one is called Helix Planetary Nebula, or NGC 7293. So they are characterized by a star at the center and then a cloud of gases which form in this ring or toroidal pattern, although not always. Sometimes we have some other patterns, but it's always is centered on the star. Now, we know that the gas forming the beautiful ring patterns is ionized because they obviously emit light. According to accepted theory, a star dies when its nuclear fuel, which powers the nuclear fusions in its core, runs out. Since it is supposed to be nuclear fusion explosions that keep a star from imploding as a result of gravity, once the star runs out of fuel, it contracts and releases its outer layers, which then become the nebula cloud around what is left of the original star. However, observation regarding the Planet X system stellar cores, which is a system of dead stars that have invaded the solar system and have made the Sun, the Earth, Venus, and most likely all the planets in the solar system their host, and for which they are drawing energy, has shown that the Sun is not powered by thermonuclear reactions, but by radioactive decay like the planets, and that thus both stars and planets have dense solid cores. You might look at some of the articles I've written about this. Article 244 entitled The Planet X System, Destroyer of Star Systems. Article 243, Earth hosting at least 3 Planet X system objects. And Article 221 entitled Stellar Core Captured by Venus and Debris in Inner Solar System. Now, here we see one of the stellar cores that are being hosted by the Sun. They're drawing energy from the Sun. As you can see, this one has a connection, a matter connection with the Sun. This is one of the ways that they draw energy from the Sun, is by directly drawing matter from the Sun's atmosphere. And this object is quite small. It's only about half the size of Jupiter. And it appears dark in all the images, suggesting that it is a new arrival at the Sun's corona, as these objects seem to start emitting light after being at the Sun's corona for some time. So the fact that it's not emitting light yet suggests that it is a new arrival. And this is one of the stellar cores that is being hosted by the Earth. In other words, it's absorbing the Earth's energy, and this one was captured by JFP in March of 2018 in a European webcam. Now, this object did not move across the sky, but remained in the same position for an extended period of time. It was thus moving with the Earth as if it was part of the Earth. And as the stellar cores in the Sun's corona also do the same thing by making this connection, they make themselves part of the Sun and thus rotate with the Sun. The stellar cores that are interacting with the Earth seem to be doing the same thing with respect to the Earth. Now, the sun's interaction with the Planet X system stellar core causes it to go completely dark at times, which would be impossible if the sun was being powered by thermonuclear reactions from its interior, as then light would be coming from the sun's interior continuously, and it would therefore be impossible for the sun to go dark. And you may look at Article 232 entitled "The Sun Can Go Dark," the implications, for more details on that. And here we see another planetary nebula, and these are not always in the ring or toroidal shape. This one, which is called the Retina Nebula, or IC 4406, has this elliptical shaped cloud that also seems to be emanating from the central star. So everything here, and there are rings that are visible behind this structure in front, or brighter structure, but they are rings that are also centered on that star. Now, this means that a star cannot undergo gravitational collapse when it runs out of fuel. What actually happens is that a star runs out of unstable nuclei in its core. And once that happens, its gravity drops. And you may look at Article 192 entitled "Neutron Stars and Fission as a Star's Internal Energy Stores," and Article 215 entitled "Dark Matter, Galactic Evolution and Star Formation" for more details. So when the star's gravity drops, the star loses its ability to hold on to its outer layers and sheds them. And you may look at Article 250 entitled "Planet X Causing Earth to Move Away from the Sun" for more details on that. However, the star loses the ability to emit light before it reaches the stage where it sheds its outer layers, and you may look at Article 184 entitled "Stellar Core Evolution" for more details on that. This is because the star's gravitational energy, or the energy generated through radioactive decay, is tied to the electrical potential difference between the star's positively charged inner core and its negative outer layers, which then gives rise to electrical discharges or lightning, which in turn give rise to the star's light emission. It would thus be impossible for a star to turn into a planetary nebula, which obviously emits a lot of light, both from the central star and from the cloud of gas. So it cannot be produced by a dead star. Now, here in this diagram, what is represented is the reason why electrons move from the core of a star to the outer layer. And all this is because protons and electrons repel each other, which can be explained by the fact that they have opposing gravitational fields. It is the gravitational interaction that causes, therefore, the electron to move away from the protons. What would keep an electron inside an atom is the fact that it's negatively charged and the proton is positively charged, and the electrostatic interaction causes, therefore, the electron to be attracted to the nucleus. But the gravitational interaction opposes that. And that means that the electron stays within a certain region of and a distance from the nucleus. It's balanced by the two forces. The electrostatic pulls it towards the nucleus, and the gravitational, which is a repelling force, pushes it out of the nucleus. So it stays within a certain region, a certain distance from the nucleus. But when there is enough energy in the particles of a celestial object, then all the protons and the electrons will have a stronger repelling force between them. And this causes the electron to be pushed outwards out of the atom and out of the core towards the outer layer of the object, which then becomes the outer layer. In the case of the sun, it's the corona. So here what's illustrated is the fact that we end up with an inner core which is positively charged and an outer layer which is negatively charged. And this causes the setting up of an electric field between the core and the outer layers. And then the object's atmosphere would be somewhere close to the outer layer. Well, the outer layer is actually part of that object's atmosphere. So we have this electric field and therefore potential difference between the inner core and the outer layer, and this leads to electrical discharges, and electrical discharges, just like lightning, it leads to the emission of light. So instead of being dead stars, planetary nebulae have to be living stars, which emit large amounts of gas, which then form concentric clouds around the star. This can also be explained by the new theory of gravity developed as a result of observing the planet X stellar cores interacting with our sun. And you may look at article 182 entitled Einstein's Dream Realized, Unified Field Theory of Electrogravitation, and from James McKenny's observation of comets and the fact that all isolated celestial objects have negative outer layers, which he describes in his book entitled Planet X, Comets and Earth Changes. Although stellar cores seem to be the exception and have a neutral outer layer instead of a negative one. Now, the mechanism which leads to stars producing a solar wind results in the formation of nebula clouds or rings around the star. This occurs because intense electric discharges in the star's outer layer results in matter creation events in which photons split into particles. Then, as a result of the gravitational interaction between particles, protons and positive ions are ejected out of the negative layer, the corona in the case of the sun, but electrons are retained. The protons and positive ions then move out towards the edge of the star system and become a part of a cloud which occurs at a certain particular distance. The protons, since they have a much lower mass than ions such as helium, oxygen, magnesium, and iron, manage to get very far from the sun and therefore become a part of the furthest cloud. But iron, which is much heavier, will become a part of a nebula cloud or ring closest to the sun. In this way, all living stars will form some kind of ring or nebula cloud pattern around themselves. And the mechanism through which protons and ions are ejected is illustrated here. Because of the discharges which occur as a result of the electric field between the core and the outer layer, photons are emitted. Photons then split into protons and electrons. And then these objects, the protons are repelled by the electrons that fill the outer layer of the object, and they will either join the core or they will be ejected out of the star into space and will move to the appropriate cloud where other nuclei of the same weight will be there. So the lightest ones will move very far out from the star, will join the nebula cloud which is furthest from the star, whilst heavy nuclei like iron will join the closest nebula cloud. And the closest nebula cloud is called a zodiacal ring, which usually occurs around the star, and which we see here. And the sun has one of these as well. It has many rings and many clouds, as most stars do. And the clouds get taller as we move away. So this would be the view of the solar system from outside the solar system, but from the ecliptic plane. We would see the sun's outer nebula cloud. The sun would be inside there somewhere. And there would be smaller nebula clouds as we move in towards the sun. And if we were to look at the sun from above the sun's north pole, this would be what we would see. We would see a large ring pattern around it. We'd possibly see more ring patterns between the sun and the outermost one. And Jupiter, which is a star as well because it forms its own rings, and also forms this kind of pattern around it. And Saturn is another one that does the same thing. So the Jupiter and Saturn are actually small stars. And for more details on the structure that forms around stars, and for the sun, it's actually called the solar capacitor, because it's positive ions that go into these nebula clouds. So these are like positively charged plates, whilst the sun's corona is like a negatively charged plate, and that forms a capacitor. Now the sun, Saturn, like the sun, although not capable of emitting as much radiation as the sun, still has extremely intense lightning in its atmosphere, which allows it to emit more radiation than it is receiving from the sun, and it also produces a ring pattern around itself, suggesting that Saturn is in fact a small star. In addition, Jupiter also creates a ring pattern around itself and also has intense lightning in its atmosphere, and is thus also a small star. The difference between a star and a planet seems to be small. Both types of objects have dense solid cores, both generate gravitational energy through radioactive decay, and both have lightning in their atmospheres. However, stars have much more intense lightning, and in addition produce rings or nebula clouds around themselves, which planets do not seem capable of producing. It thus seems that the presence of rings or clouds of gas around an object is what should be used to determine whether they are a star or a planet. And here we see lightning in Jupiter's atmosphere. And this lightning obviously allows Jupiter to emit some visible light from that location in its atmosphere. And this is also the way that the sun emits light, except in the sun there is much more of it. So the whole atmosphere of the sun seems to light up with light emission. So in conclusion, the presence of a colorful cloud of gas around the star cannot possibly indicate that the star has died. Quite the opposite. Only a living and very active star will be able to produce a huge nebula cloud or ring pattern around itself. Planetary nebula are therefore products of a living star, not one that has died. And here are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.